7.3, example 5, graphing a system of inequalities. Graph the given system of inequalities. So similarly to the previous problem, we have an equation that we're going to graph. We're going to have shaded regions. We're going to have test points, all of that. And same thing over here. It looks like we have two parabolas here. So let's try to get it in parabola form. So let's see. In parabola form, we have x squared minus y is less than. Actually, let's just do different colors. We'll have this one in gray. We'll have this one down here in green. All right, starting off with gray, let's get it into a form where we could actually graph it. Let's graph the equality first. So we have y is equal to x squared. Okay. So y is equal to x squared. And we have a less than or equal to sign, which tells us that we're going to have a solid line. Let's do our test point. So our test point, sadly, we cannot use our origin. We cannot use 0, 0 because 0, 0 is one of the points that make up this graph. We could test any other point that we want. I'm going to choose when x is 0, y is 5. Let's test that part out. Let's test the point. We'll say that's 1, 2, 3. We'll test the point 0, 3. So test x squared minus y less than or equal to 0. And again, the reason why we're doing this part is just to see where we're going to shade. So we have -3 less than or equal to 0. This is true. So that means that we're shading all of that area. So I know it's going to look a little bit weird right now. Our solution is only going to be where the two regions meet. Because just like a system of equations, we have one solution. It's where the two meet. Here, the only solution is where the two functions have the shaded region. So far we have that. Let's see what the other equation is going to give us. So here, let's graph this part, 2x squared plus y. Let's do equals 12, so that way we could see what we're graphing. Here we have y is equal to -2x squared plus 12. So plus 12 is going to be way up here. So that's 3, 4. So 2, 4, 6, 8, 10. Let me fix this really quick off camera. I'll be right back. All right, there we go. Much better. So we have that. So we have a parabola that opens downward with a vertex at 0, 12. So 0, 12 is going to be right here. 0, 12 opening downward and stretched vertically by a factor of 2. So it's going to come down this way, come down this way. This time, the point 0, 0 is not on the graph itself, so we could use it. One more important thing that I didn't even check beforehand is, do we have solid or dotted? I'm sorry, dashed. Solid or dashed. So we have solid because it's less than or equal to, just like we would have a solid circle for less than. Yep. So we have that. Let's test our point. We're going to test the point 0, 0. So we're using our inequality. So 2x squared plus y less than or equal to 12. So we're testing the point 0, 0. So 2 times 0 squared plus 0 less than or equal to 12. We have 0 less than or equal to 12. 0 is less than or equal to 12. So we're going to do a little that there. And let's use purple for this one. So this is the solution to that second equation. But again, the only parts that count are going to be this middle region. So the only parts that are the solution to this system of equation is going to be this middle region. Let's do a really obnoxious color. Let's do like a dark gray so that the world knows that we did this work here. We tested these test points. And we know that this is our solution. So here is our solution. The other parts are not the solution. Technically, we could even delete these. There we go. And that's a solution to this system of inequalities. If you have any questions, please feel free to ask. Otherwise, bye.